Okay, this is exercise 4, the Humble Company. Yeah, in chapter 6, and what it is a good example of high-low. And remember, we've got two different ways that we're going to estimate costs for this chapter, and one of them is high-low, and then the other one is regression. So we have, in the first place, we've got a cost column. There's always going to be costs associated with this, and then some level of activity that relates to the cost. And you've got to remember that we identify the high-low from the activity level, okay, not from the cost level. And you're just going to have to be careful and catch that. And as soon as you find your low level of activity, circle the whole thing to make sure you pick up that 100,000. And for the high level activity here, it's 240 for the high level feet of lumber, so that would be 280 in costs. Now, in this example, these are, in fact, the highs and lows, but that's not always the way it is. Okay, so be careful with that. So we're always going to use the activity level to figure out the, what the high and low is. And the first thing they did was draw a scatter plot and then plot it, and it looks like it's a linear relationship, so that's good to know. And then the next piece was to apply the high-low method. And you want to think about it in two pieces. Okay, in the first place, though, what we're aiming for is to get a cost equation. Okay, we want to see a y equals mx plus b, or the way I like to do it is the total cost equals fixed cost plus variable cost times the quantity. Okay, this substitutes better into our problems than the formula for a line. So what do we have here? What we're going to do is take the highest. It's always going to be dollars over units. Okay, so we're going to take the change in cost. So cost of the highest activity point minus cost of the lowest. Okay, so the change in dollars from high to low divided by the change in activity level. And the idea is that if there are no fixed costs in the change, okay, the change must be only variable cost. It has to be. So if we divide that by the change in units, we could get our variable cost. So our variable cost here is like 280 minus 1. This would be 180 divided by 240 minus 60, which would give us $1 per unit. Okay? So it's change in dollars over change in units, and now we've got our fixed costs, or our variable costs, so we can substitute it into the formula and figure out what our fixed is. So we can take this level, the total cost at either the high or the low, but nothing in between. Okay, it'll work for either one, but you can't go and just think this line is actually drawn like this. So we're going to use that data point and that data point. You can't see that. Okay, the high and the low number, and then that's where the line goes. So it kind of approximates this line, but it's not perfect. Okay, a regression would give us a better number. So anyway, we've got our dollar here. I'm going to start at the high level of activity. So the total cost is 280, and that equals our fixed costs, which we're looking for, plus $1 of variable cost times 240. Our fixed cost is 40,000. Okay, so then our total cost, our cost function, would be y equals 40,000 plus 1q. Okay, that's the cost equation. All right, and you can call we can call this total cost. Okay, but two pieces to it. First, figure out your variable cost, and then do the fixed cost. I think there's a couple more pieces here. And then they ask, using high-low, what would the cost be for 90 feet of lumber? So we would just substitute the 90 in here for the x, 40,000 in fixed cost plus $1 times 90 feet. Okay, that's it. All right.